welcome to this free CCNA Packet Tracer practice lab. You can download the lab file from the link in the description. In this lab, we will be working with two routers, R1 and R2, and two switches, switch 1 and switch 2. We will configure and test a serial connection between the two routers. Note that I have already configured the host names of each of the devices beforehand. Try to complete the lab yourself. Step 1 asks us to use CDP to discover which interfaces are used to connect the routers and switches. If you have the option, always show port labels in Logical Workspace in the Preferences menu of Packet Tracer enabled. The labels will appear next to the devices, but I have this option turned off. We will use CDP, or Cisco Discovery Protocol, to identify the interfaces. CDP is a very useful tool, and I will create a lab dedicated to using CDP in the future. But for this lab, all we need to know is one command, that is show CDP neighbors. Let's give it a try on switch 1 first. I'll type enable to enter privileged exec mode. This is where we use the command, show CDP neighbors. As you can see, switch 1 is connected to R1, and the local interface, meaning the interface on this device, is Fast Ethernet 01. Let's go to R1. Enable show CDP neighbors. R1 is connected to switch 1 on the Fast Ethernet 0 interface. But something's missing. Where's R2? Well, because I have link lights enabled on Packet Tracer, you might have noticed something is wrong. Let's troubleshoot a little bit. Think of potential causes, first at layer 1, or the physical layer of the OSI model. Is the cable plugged in? Yes, it is, as you can see here in Packet Tracer. Are the interfaces turned on? Let's check. I'll use the show IP interface brief command to check. Well, we were going to use CDP to discover which interface R1 is connected to R2 through, but as we can see, there is only one serial interface, serial 0, and it's administratively down. That means if we do a show run command, which I will do now, we should see the shutdown command on the serial interface. I didn't configure this is by default. Let's fix that. Conf t interface serial 0. No shutdown. Let's check on R2 also. Enable show IP interface brief. Again, it is shut down. Conf t interface serial 0. No shutdown. Okay, now let's return to R1. This could take some time, but if I enter show CDP neighbors again, I should see R2. There it is. R1 is connected to R2 through the serial 0 interface. Let's run the command on R2. Take N to return to privileged exec mode. Show CDP neighbors. R2 is also connected to R1 through the serial 0 interface, and switch 2 through the Fast Ethernet 0 interface. Finally, let's move on to switch 2. Enable show CDP neighbors. As you can see, switch 2 is connected to R2 through the Fast Ethernet 01 interface. Step 1 is now complete. Step 2 asks us to identify which end of the serial connection is DCE and which end is DTE. In serial connections, one side is DCE, or Data Communications Equipment, and one side is DTE, or Data Terminal Equipment. The most important difference between the two is that the DCE device supplies the clock signal that paces the communications, which we'll adjust in the next step. To identify which is which, let's go to R1 first. We'll use the command show controllers serial 0. If we just typed show controllers, we would be overwhelmed with information about every interface on the router. So make sure to specify serial 0. Can you find what we're looking for? There it is. And this side is the DCE. You can also see the clock rate mentioned earlier. Well, now we know which side is DCE. That means R2 should be DTE, but let's check anyway. Let's hop on to R2. Show controllers serial 0. As expected, R2 is DTE. Step 2 is now complete. For step 3, we have to set the clock rate on the DCE in to 64 kilobits per second. So let's go back to R1. We have to configure the serial 0 interface, so conf t, then interface serial 0. Now we are in interface configuration mode. The clock rate is set with the clock rate command. Let's use the question mark to see what options we have. As you can see here, these options are listed in bits per second. Our task is to set the speed to 64 kilobits per second, which is 64,000 bits per second. So let's do that. That's all for step 3. We don't have to do anything on the DTE side. Step 4 tells us to set the IP addresses of the serial interfaces of R1 and R2 to 192.168.0.1/24 and 192.168.0.2/24 respectively. We're already in interface configuration mode on R1, so let's configure R1. IP address 192.168.0.1. Now, how do we set a /24 subnet mask? If you've already studied subnetting, this is something you should know. If not, don't worry about it. It's 255.255.255.0. There we go. Now let's do the same on R2. Conf t, interface serial 0, IP address 192.168.0.2, 255.255.255.0. That's all for step 4. Finally, step 5 asks us to test connectivity between the routers. Since we're already on R2, let's do it from here. Type N to return to privileged exec mode. The IP address of R1's serial 0 interface is 192.168.0.1, so ping 192.168.0.1. As you can see, we have connectivity between the routers. That's all for this lab.